Okay, we're going to jump in and try to finish up sum of 2.4. Starting with example 6, we've got g of t equals negative 7 over 2t minus 3 squared. So we need to rewrite that friendlier. It's always easier if we're able to make it where everything is in the numerator. So now when we're ready to take our derivative, we can do the general power rule where this comes down and it's, oh, let me back up. You notice how we have a chain rule situation? We have an outside function, and then we have the inside, the 2t minus 3. So we'll treat 2t minus 3 as a thing, and then we'll just take the power times the constant times the thing to the 1 less, and now we need to do the derivative of this. To finish it up, we'll make that 28. We'll kick the 2t minus 3 to the denominator and give it a positive power. Okay. This next one I'm going to do is example 7. F of x equals x squared times the square root of 1 minus x squared. Let's rewrite that simpler with powers instead of roots. So square roots are to the 1/2 power, because all of that is to the first power and your root is a 2. Now this is a product of two things, so we have to do product rule when we take our derivative. And this is our product rule. So first, times derivative of second. That's all of this. So we'll take chain rule here. See how we have an inside function, the 1 minus x squared, and the outside function was the square root, so we're going to have to do the chain rule. So the 1/2 comes down and is multiplied by the 1 that's there. 1/2 of 1 minus x squared to the 1 less power times, now we need to do the derivative of the inside. Now as we try to, that's first times derivative of second plus second times the derivative of the first. Okie dokie. Let's see if we can clean this up a little bit. X squared, 1/2, and negative 2x. Those can all be multiplied together. 1/2 of 2 is negative 1. So we have negative x to the third. Make sure you see that. And then parenthesis 1 minus x squared to the negative 1/2 plus down here, we'll just make it 2x times 1 minus x squared to the positive 1/2. Okay, I want you to notice that both of these terms have a 1 minus x squared, and the book would like for us to practice factoring out the least powers. That's what they've titled this section, or this example. So this is the least power, the negative 1/2, compared to the positive 1/2. And then also, if you look at these, you've got an x that we could factor out. And we'll factor out the least power. And then we'll do a bracket and we'll write down what's left. So right here we would have a negative x squared left. And we factored all of that, it's gone. Plus, for here we have a 2 left. And let's see, when we factor it's like dividing. So when we divide out the negative 1/2, it's like we had a 1/2 and we're dividing it out. So when we divide we subtract. So I would have 1 minus x squared to the 2/2 or just to the 1 power. So again, it's kind of like you had, and you divided it out. Factoring is like dividing. So it's, we divided it out. So 1/2 minus that negative 1/2, because when we divide like bases, we subtract exponents. would be 2/2 or just 1. And then to finish it up, I think, nope, they did not let us leave it like that. They put the x on the top and they put the 1 minus x squared, oops, square root in the bottom, and then they did a bracket and they wrote all this other, negative x squared plus 2 parenthesis 1 minus x squared. Sorry, it's a little squishy. You can look in the book if you need to. It's on page 133. All right, example 8. We'll switch back to black. F of x equals x over cube root x squared plus 4. We can rewrite this friendlier, or we can see that as quotient rule. If we rewrite it friendlier and leave it in the denominator, then it's x squared plus 4 to the first power over the third root, power over root. I think I would do that and do quotient rule. You could move it to the top as a negative 1/3 power and do power rule. It's up to you. So low d high minus high d low. When we've got to take the derivative of this, it's an inside function with an outside function. So take the 1/3 down to the front of the x squared plus 4 to the 1 less power times the derivative of x squared plus 4. All over low squared. So that's x squared plus 4 to the 1/3 minus, let's combine this and this and this. Those are all getting multiplied together. X times 2x is 2x squared, times 1/3 is 2/3 x squared, times x squared plus 4 to the minus 2/3, all over x squared plus 4. Power to power we multiply, and you make 2 a fraction, so it's 2/3. Okay, let's see, what could we do? We could factor out on the top that least factor like we were doing. So when you just look at the top, this negative 2/3 is the smallest, so we could factor that out. Which would leave, so now when we look at this, we have a 1/3 and we're subtracting the negative 2/3. So that's just to the first power. Minus, let's see, we factored all that out, so it's just minus 2/3 x squared all over x squared plus 4 to the 2/3. Since this is multiplied by all of this, I can make that go to the denominator. And if I move that to the denominator, it leaves x squared plus 4 minus 2/3 x squared in the top. And when I move it to the denominator, I'll just show it, x squared plus 4, it becomes positive 2/3, and there's already an x squared plus 4 to the positive 2/3 down there. So these are like terms. Positive 1 and negative 2/3 gives us positive 1/3 x squared plus 4 over, when I multiply like bases, I add their exponents. And let's see. What do I want to do with that 1/3? Let's get a common denominator right here. Times 3 times 3. This is one of the heaviest simplifying and really heavy algebra sections. So that is 1/3 x squared plus 12/3 all over x squared plus 4 to the 4/3. So that is x squared plus 12 over 3 over x squared plus 4 to the 4/3 over 1. So we can flip that up and multiply by the reciprocal. So it's a problem that keeps on giving. X squared plus 12 in the top and 3 parentheses x squared plus 4 to the 4/3 in the bottom. Didn't look like it was going to be that bad. All right, example 9. I think this is where we will stop for the day. Yeah. Example 9, we've got y equals big parenthesis 3x minus 1 over x squared plus 3 all to the second power. Wow. Do you see how that's a chain rule? All of this is my inside function and my outside function is squaring. So we can do this derivative with the chain rule. We can bring the 2 to the front of all of this and make that to the 1 less power times, now we need to do the derivative of this, which is a quotient. So let's go ahead and set up a bracket. Low d high minus high d low all over low squared. All of these numerators are multiplying. Let's see, so let's simplify this a little bit. This 1, power of a 1, is doing nothing, so my parentheses really don't mean anything other than I can multiply by the 2. So let's go ahead and distribute the 2 here over here. Let's distribute. Let's distribute. Let's see. Getting ready to multiply these denominators together, but not quite yet. I'm going to simplify the numerator here a little bit. Okay. Are they going to make us multiply that out? They did not. They did not make us multiply the numerator out. We could leave it like that, and then times negative 3x squared plus 2x plus 9. And in the denominator, one of these times 2 more of those is 3. When we multiply like bases, we add their exponent. And they actually let us leave it like that. Right, I want to show you chain rule. Using dy dx equals dy du times du dx. Okay. All right. So I'm going to try to show you this formula rather than me just being a little lazy. I'm going to call y all of this. And I'm going to call u the inside part. That means I can rewrite y in terms of u. So y is the inside part cubed. Okay. So now let's do dy over dx equals. This says take the derivative of y with respect to u. Well, this is the equation right here that has y being defined with u. So the derivative of this y with respect to u is 3u squared times, and now this is saying take the derivative of u with respect to x. Well, that's this. This is u defined with x. So the derivative of u with respect to x is 2x. And then the last thing we need to do, instead of calling this u, let's go back and write what u is equal to. So that is 3x squared plus 15 times 2x, which is 6x to the third plus 30x. If you like that, I can work on that way a lot during class. What I was doing with you all was I was saying, notice it's an inside part with an outside part, and kind of treat it as a u. So it was 3 times that u to the 1 less, and then we would do times u prime. So I would have you say, now we need to take the derivative of the inside. So that's 6x times squared plus 5 to the second. I paused it for a second because these weren't working out the same way. And it's because right here, when I back substituted for my u, it was supposed to be u squared, and I dropped that. So I can actually not do any of this simplifying that I did because I dropped my squared. All I can do is 3 times 2x times x squared plus 5 squared. I knew I made a mistake somewhere, but I wasn't sure where it was.